Hello, and welcome to this demonstration of Jeda Networks Fabric Network Controller. In this video, we will give you a little background information on Jeda Networks and the Jeda Fabric Network Controller. Once we have explained the basics of Jeda's solution, we will walk you through a demonstration showing how quickly the FNC can establish a 10 and 40 gigabit connection between server and storage array. Jeda Networks is a key component of the software-defined data center. Servers, networks, and storage have all been virtualized by various vendors, but not the glue that connects the servers to the networks and storage. That's where Jeda Networks comes in. The Fabric Network Controller, or FNC, creates the fabric connections from servers to their storage over a network. The result is a fully virtualized storage network running on standards-based network equipment. Jeda's approach to storage network virtualization results in a number of advantages to the IT organization and their customers. Because Jeda's FNC can work with standard DCB-enabled switches, IT organizations can now choose their network switching equipment based on the features they need and at a price that fits their budget. Jeda's FNC abstracts the storage network from the physical network, greatly simplifying the configuration process. Converged infrastructure means that data centers no longer need to purchase and install a duplicate storage network with all the associated adapters, cables, and switches. Because Jeda is just software, it is completely speed agnostic. As soon as 100 gigabit converged adapters are available, Jeda can support the integration with the storage network. Finally, Jeda's FNC connects applications systems to their data. Where the application system resides or what port the storage array connects to is irrelevant to the storage network administrator. Initial configuration is greatly simplified, as well as moves, adds, and changes down the road. Let's see how Jeda accomplishes this. Jeda's FNC is delivered as a pure software network controller. It runs as a virtual machine on the network and connects to managed switches over a standard DCB-enabled network. The FNC provides the essential network services necessary to support a storage network. Keep in mind that Jeda's FNC does not require any special drivers or software on servers or storage. The FNC only requires that servers and storage are FCoE compliant. Initially, the FNC sends rules to the switch to recognize SAN connections and forward SAN logins and events to the FNC. This is only performed once per switch. From that point forward, simply plugging an FCoE-enabled device into the switch will logically connect that device to the FNC for registration in the name server. Configuration of zones and security will happen automatically. Here's an example of that initial connection. When a server or storage array plugs into an FNC managed switch, the device sends its login request to the FNC controller to log in to the storage network. The FNC adds the device to the device table and looks up any device connections defined in the zone or security tables. If the zone table defines a connection from a new device to any device in the name server table, the FNC sends rules to the switch to enable a secure connection between the devices. Data flows as layer 2 Ethernet at wire speed. In our demonstration, we have 4 switches. These switches have already been plugged in and connected as seen in the diagram, including configuring the lag connections between switches. In a later video, we will show you how to use the FNC to configure switches and link integration groups, or lags. Note that this is a multi-hop network with 2 top-of-rack switches and 2 backbone or spline switches. Any request or response from the server to storage must traverse at least 3 switches in each direction. Here are our demonstration systems. This is our 40 gigabit Windows 2012 server. On this system, you can see that we have the disk manager up so we can see when new disks are added to the system. Here is our 10 gigabit Windows 2012 system. Here also we have the disk manager up to show us when new disks arrive and are available. This is the command line interface to the FNC, also known as the CLI. The CLI is a secure remote shell into the Jeda FNC controller application First, we'll look to see what devices are on our network. We do this by typing in the show nstable command. Show nstable shows us what devices have logged into the name server. As you can see, no devices have registered with the FNC. Devices can only register with the FNC via the FNC managed switch. To manage a switch, we activate the switch in the FNC. Let's activate our first switch on the server side. We do this by typing in the activate switch command. Now that the switch is activated, let's see what's in the name server table. Notice that now we see two entries in the name server table. Each of these entries represents a login by one of our servers. On the left-hand side of our table, we see that one server is connected to port 2 on switch 1 and one server is connected to port 49 on switch 1. On this switch, port 2 is a 10 gigabit port and port 49 is a 40 gigabit port. Now let's activate the storage array switch. Looking at the name server table again, we now see more entries in the table. We now show an additional 6 device addresses in the name server table. In our demo network, we have all storage devices attached to switch 2. These addresses represent our 2 demonstration arrays. And here's another array with 4 10 gigabit MPIO links. For this demo, we'll just use the ESOS arrays, these 2 here. Notice that we only have a C drive on our 40 gigabit test server. To connect additional drives to the server, we create a connection from server to storage. A zone is a secure connection among 2 or more storage networking devices. For example, between our 40 gigabit server and the ESOS array. The FNC places rules in the switch that block devices that are not in the zone from communicating with devices that are in the zone, or even from seeing network traffic among zone members. A zone set is a collection of zones. We can have multiple zone sets defined in the FNC, but only one may be active at a time. Let's create a zone set container named test. Now that we have the container test, let's show that it is empty. Using our container test, let's now create a zone with the 40 gigabit server and the first 40 gigabit ESOS array, LD2. And now we'll add that zone to the test container. With that done, we can add our members to the zone. We add members based on their worldwide port name, also known as WWPN. Worldwide port names are unique to each port on any SAN-enabled device. They're similar to a MAC address on Ethernet. Here's how we add a member to a zone. We use the add zone member command with the WWPN for the device and the name of the zone. That adds our Windows server, now for the array. Again, add zone member with the address of the LD2 zone name. The zone is ready. Now let's activate the zone in the zone set. Notice that in all of our zoning commands we include the Fabric VLAN 2001 to let the FNC know where to apply the changes. You might have noticed that several disks showed up on LD2 server when we activated the zone. That's how easy it is to securely add disks to a server on an FNC-enabled SAN. We can bring up the obligatory iometer application to demonstrate the performance of a truly 40 gigabit SAN. Let's set the test to only perform one 4K I/O at a time. This will give us an idea of the latency for a single I/O. Around 90 microseconds end-to-end latency. Considering that the storage array and server account for nearly 75 microseconds in this case, that's pretty amazing for I/O that's traversing 3 switches twice. Now let's add a zone for a 10 gigabit server. This time I'll add the zone to the server using a simple 5-line script. Notice that the LUNs immediately show on the disk manager for the 10 gigabit server. Let's do a quick iometer test on the 10 gigabit server and see how much throughput we can achieve. We'll configure our test to run with 5 outstanding IOs of 1 megabyte each. The 10 gigabit link is running near theoretical maximum performance for a 10 gigabit link. Not bad. Now let's go back to the 40 gigabit server and see how fast it will run. And now we start iometer. Over 4 gigabytes per second. Our demonstration is already running faster than the next generation of 32 gigabit fiber channel. So in this video, we have shown you that Jeda Networks Fabric Network Controller can leverage standard DCB-enabled switches. We can configure multiple SAN connections in less than 5 minutes. A Jeda storage network runs at wire speed. Even in a 4-switch network, the storage traffic demonstrated less than 100 microsecond round-trip latency. Jeda's FNC supports 10 and 40 gigabit connections today and is ready for 100 gigabit tomorrow. And finally, the configuration of a Jeda storage network is simple. In only a few steps, we connected 4 devices in a high-performance storage network. For more information on the FNC and Jeda technology, we have several white papers on our website at www.jedanetworks.com. For additional information, feel free to contact our sales force at sales@jedanetworks.com. Thank you for taking the time to watch this video and learn about Jeda Networks.